There we go. Can you hear me now?
Yes, yes.
Yes, you got my name right. Paranoia.
Paranoia. Bob Noya. So I won't make too many announcements, but a couple things. Bob will give his talk. If you have questions, please put them in the chat and we'll address questions at the end. So he's got a really great talk that he's going to give us, and there'll be plenty of Q&A, but we'd like to save questions to the end. So if you can keep yourself muted as well, that'll help with background noise. We are recording these. We do have a YouTube channel where we post them. So if you want to share the talk with anybody and want to see it later, that'll be available. Harris, one of the organizers, put it in the chat. So that's available for people after the talk. Okay. Well, without further ado, let me introduce Bob Noya. He's an award-winning freelance journalist based in Hershey, Pennsylvania, who specializes in science reporting. From 2008 to 2014, Bob served as editor of Sky and Telescope, one of the world's most respected astronomy magazines. He's written, several books, given hundreds of talks on astronomy. He's got lots of great articles out there, including one in the February 2021 issue of Astronomy Magazine, which was the cover story about supermassive black holes. So we're glad to welcome Bob tonight to talk about the recent enigmatic radio signal from Proxima Centauri. I won't say anything more about that, but I'll turn it over to Bob. Welcome, Bob.
Hey, thank you. And I guess we should do the screen share now. Are we good?
Looks good. If you make it full screen, there you go. Perfect.
Okay, is everybody ready to rock and roll here?
Let's go.
Okay, great. So I just want to, first of all, I want to thank Steve for inviting me and setting up tonight's meeting. I want to thank the Asheville Science Tavern. I only wish I could come and be there with you in person tonight, especially since you meet at a tavern and I'm a big aficionado of craft beer. But I do want to thank all of you for Zooming in tonight, especially now that we're in savings time. It's amazingly light out where I live for 6:06 in the evening. So tonight I'm going to be discussing whether or not we have picked up a radio signal from an extraterrestrial civilization. And making matters even more interesting, if that's not interesting enough, the signal appears to be coming from the direction of the nearest star to the sun, called Proxima Centauri. And I'll be talking more about the star later. So the story has gained a lot of traction on the internet. I wrote a news story about this for astronomy.com, which you can easily find. And I want to stress right off the bat, this signal is probably not from ET. But if it is a signal from ET, it raises a whole set of profound questions about whether and how we might respond and about humanity's place in the universe. So I'm hoping, whatever this signal turns out to be, I'm hoping this discussion will stimulate all of you to think about these really interesting questions. So the discovery was made possible by an ongoing research effort known as SETI, which stands for the Search for Extraterrestrial Intelligence. I suspect many of you have heard of that term before. So different research groups have been conducting SETI efforts at a fairly low level since the early 1960s. And they mainly focus on using large radio telescopes to listen for radio signals coming from other civilizations. So radio waves, probably all of you know this, but just in case, radio waves are very easy to confuse with sound waves, but they're two entirely different things. Sound waves are basically pressure waves, either in the water or the air, whereas radio waves are a form of light, just like visible light that we see with our eyes, X-rays, visible light, microwaves, etc. So space is filled with radio waves from natural sources. This would include normal stars like the sun, neutron stars, black holes, galaxies, and all sorts of other objects. So, starting many decades ago, astronomers have built large radio telescopes to study the radio emission from these natural objects. And you can see here, radio waves are off to the left, which means they have the longest wavelength, which means they're the least energetic form of light. So starting in the late 1950s, scientists realized that radio has a lot of advantages for civilizations who want to communicate across the vast distances of space. First, it's relatively easy and inexpensive to transmit very powerful radio signals that can be detected at great distances. Number two is radio signals are a form of light, so they travel at the speed of light, the fastest speed in the universe. And then third, and as I'll explain shortly, civilizations can transmit radio signals in such a way to make them easily distinguishable from natural radio signals. Whoops, why is that not advancing? There we go. Okay, so the Proxima Centauri signal that I'll be talking about tonight was picked up by what is currently the most advanced SETI project in the world called Breakthrough Listen. Now, it was funded by this tech billionaire at the upper left, Yuri Milner, in 2015. He and other investors donated $100 million to this project. Now, this Breakthrough Listen uses a number of different radio telescopes, but the two main ones are the Green Bank telescope in West Virginia, which isn't that far from Asheville. And then the one of interest tonight is the Parkes Radio Observatory in New South Wales, Australia. So, Green Bank is listening to the Northern Hemisphere stars. Parkes is listening to Southern Hemisphere stars. So the Parkes Radio Telescope in Australia picked up this signal, and remember this date, April 29th, 2019, a little less than 2 years ago. The telescope was observing Proxima Centauri to catch radio emission from very powerful flares being shot off the star. This star, even though, as I'll explain, it's a very little star, it gives off very powerful flares, more powerful than ones coming from the sun. But then late last year, an intern working for the project noticed an unusual signal buried in the data. And what this intern realized is 5 times that day, on April 29th, 2019, the telescope was pointed at Proxima Centauri for 30 minutes. Every time the signal appeared, when the telescope turned away from the star about 30 degrees, the signal went away. So that's really, really interesting. But it's important to recognize that radio signals can find their way into the beam of the telescope, into the receiver and detection equipment when the telescope is not pointed in that direction, or when a telescope's pointed in one direction, signals can still leak into the telescope. And that'll become important for what I'll talk about later. So the team then, when they realized there's this interesting signal in the data, they ran it through all sorts of different filters or computer algorithms to try to rule out human radio signals such as satellites, interplanetary spacecraft, aircraft, cars, and even microwave ovens, anything that humans make that can produce a radio signal. So the signal survived all of those filters, which flagged it as a possible ET signal. So the team is calling it Breakthrough Listen Candidate 1, or BLC1. So for the rest of tonight, I'll mention BLC1. Okay, now the finding was not intended for the public, okay? But somebody, probably someone on the team, leaked the story to the British newspaper, The Guardian, which broke the story on December 18th, 2020, just about 2 months or 3 months ago now. So articles have since appeared in Scientific American, National Geographic, the New York Times, the Atlantic. I wrote the story for astronomy.com, and many other reputable publications and websites. So the team, I mean, this is not National Enquirer. These are reputable media outlets. So the team has not published a scientific paper or posted any specific information on its website. So the public and even the scientific community really has very little information right now about the signal. But we do know that the team is apparently working on 2 papers for scientific journals, but I don't know when they will be published. My guess is sometime fairly soon in the next several months. Okay, so the team has not stated how strong the signal was, but it was apparently weak as it was received here on Earth. But, you know, from where it was sent, if this was sent from like another star, you know, it was a very powerful signal transmitted into space, but by the time it got to Earth, it was weak. But what made the signal really, really interesting is that it was very narrow in bandwidth, meaning all of the energy of the signal was basically concentrated into a very narrow range of frequencies, as we see here with this purple spike in this diagram. So this is really important because when humans transmit radio signals, we like to make them narrow band because that's a very efficient way to, you know, take all the energy of your signal and, you know, pack it into a narrow range of frequencies. It also means that your signal is going to stand out against background, you know, background noise. So that's why, for example, you know, if you're using, you know, a car tuner tuning to a radio station, you want to pick up your favorite radio station, you've got to tune it to, you know, very precisely to pick up the signal. But what's interesting is that Mother Nature doesn't care about efficiency. So all these natural radio sources like stars and galaxies spread these radio signals across a broad range of frequencies like the red hump at the bottom. So as a result, and I've even asked radio astronomers, we don't really know of any natural radio sources that really produce very narrow band signals. So the fact that this is a narrow band signal indicates that whatever produced this signal, it was artificial in nature. It was not a natural source. So BLC1 was detected at a frequency of 982.02 megahertz. That's 982.02 million cycles per second. And you can see it indicated that frequency by the red arrow at the bottom. Now, this is in a relatively quiet part of the radio spectrum where there's not a lot of noise from natural sources. It's also a part of the radio spectrum that's not commonly used by humans or spacecraft, which makes it even more interesting. Now, on the flip side, notice it's almost exactly 982. It's very close to an integer value. I think that indicates a human source because, you know, the integer value is, you know, cycles per second. Cycles is a human, you know, measurement of time. Why would the aliens use like our unit of measurement? Presumably, you know, they would have their own unit of measurement. Another thing that the team told the media is that the signal was monotone, meaning it's a very simple carrier wave like the black line at the top. In other words, whoever sent the signal did not modulate it either in amplitude like we see an AM signal in the middle or in frequency like the FM signal on the bottom. They didn't modulate it to encode more complex information like an AM or FM radio signal. So, you know, humans, when we, you know, we send radio signals and encode it, you know, so you can listen to music, you know, listen to people talking on the radio or, you know, data. So this was an unmodulated signal. But because this signal had a very narrow bandwidth, and the fact that it appeared when the telescope was pointing toward Proxima Centauri and not when it was turned away means it's probably the best candidate SETI signal since the Ohio State University Big Ear Radio Observatory, which you can see at the bottom right, picked up the famous WOW signal on August 15th, 1977. So the name WOW signal comes because the radio astronomer named Jerry Eman was looking at the recorded printout that was, printed out on a computer, and he noticed this very, very powerful signal. It was so powerful that you needed to like go into the letters of the alphabet. The signal strength would go 0, 1, 2 through 9, but it went way beyond 9. It went all the way up to the letter Q. So you can see the profile of the signal at the upper right. This was a very, very powerful signal. It lasted 72 seconds as the source passed over the observatory. Now, the signal came from the direction of the constellation Sagittarius, and you can see in this star map, it's a little bit to the left of the famous teapot of Sagittarius. Although the precise coordinates are not known, you can see the possible origins on the right here with these reddish ellipses. That kind of narrows. The signal came from somewhere within those ellipses. Now, there were no known satellites or spacecraft in that general direction at the time that Big Ear picked up this radio signal. Now, radio astronomers have since listened to those coordinates on the sky a number of times, but the WOW signal has never repeated. So the origin remains unknown, and my guess is we will never know what produced the WOW signal. But what we can say is that it had all the hallmarks of a signal from another civilization. But sadly, this is kind of a sad part of the story. Big Ear was torn down in 1997 to build a golf course. Okay, so then the question is, what about BLC-1? Is it an ET calling card? Now, the executive director of Breakthrough Listen, Pete Worden, said, he told, I think it was Scientific American in an interview, that there's a 99.9% chance that it was radio interference from a man-made source, probably something on the ground. And you can, see the tweets that he sent out the day after the Guardian story came out. But, this was, 3 months ago. The team has not yet announced, a source. If they found out, if they could identify, the source of interference, they could get this over with quickly and just announce that it was, a car, airplane, or microwave oven or whatever. So, until the team completes its analysis, I would argue it has a strong incentive to be very cautious in any statements it makes to the media and public. But please be aware that previous SETI efforts have picked up, interesting radio signals that ultimately turned out to be man-made interference. My guess is we're going to know one way or another in the next few weeks or months. Okay, so I'm going to shift gears now and talk about the star Proxima Centauri, which is the bright reddish star in the middle of this telescope image. Now, this star is in the southern hemisphere constellation of Centaurus, meaning we can't see it from, our latitudes like in North Carolina and my latitude in Pennsylvania in the United States. It's just too far south. It's always below the horizon. But even if it was, a northern hemisphere star, it's 11th magnitude. That means it's about 100 times too faint to be visible to the naked eye. It only looks bright in this picture because, this is a telescopic image. Now, this map shows the nearest distance, the distances to the sun's nearest neighbors. It's a little bit misleading because the stars are in different directions. And of course, space is also three-dimensional. But you can see that Proxima is relatively close to us. It's only 4.25 light years away. It's actually the outermost member of a triple star system where the two major stars in the system are Alpha Centauri A and B, which are both fairly similar to the sun. They orbit each other fairly close to each other. Proxima is much, much farther away. So it kind of orbits those two stars almost as if they were just one center of gravity. Now, 4.25 light years is still an enormous distance by human standards, because if you remember, a light year is about 6 trillion miles. It's the light distance that light travels in 1 year. So this star is about 25 trillion miles away. That sounds like a long way away, but by galactic standards, you know, it's our next door neighbor to the solar system. Now, this star is a wimpy star compared to the sun, and that explains why it is so faint that we can't see it with the naked eye, even though it's very close to Earth. Its total energy output is less than 1% that of the sun's. And as you can see here, it's a small star. It's only about twice the diameter of Jupiter and Saturn. It's also a lot cooler than the sun, about 5,000 degrees Fahrenheit cooler. That's why it's reddish. It belongs to a class of stars called red dwarfs. So I would say these are kind of pathetic excuses for stars, but what they make up for and how wimpy they are in their feeble energy output, they make up for that in numbers, because they account for about 3/4 of all the stars in our galaxy. And one other thing you need to know about this star is that it's 5 to 6 billion years old. So it's a little bit older than our sun. So if it has, you know, if there's life got started on any planets, and I'll talk about that in just a minute, there is time for that life to evolve into complex or even intelligent life. So despite the diminutive size and feeble energy output, Proxima Centauri has a planet. In fact, we know it has at least two. So here we see it on the lower left. I love this cartoon bragging about its planet, which was discovered by astronomers in 2016, about 5 years ago. So here's an artist rendition of this planet, which is in the foreground. The Proxima is the bright orange star at the left. You can see Alpha Centauri A and B as those two little white dots, you know, in between the planet and star. You know, they are, you know, very, very, they are thousands of times farther away from the planet than Proxima Centauri. So astronomers discovered this planet using a method known as radial velocity, also known as the wobble method. They're basically discovering the planet's gravitational input on the star. So we're not actually detecting the planet directly. And fortunately, the planet does not pass in front of the star as seen from Earth. So we can't measure its diameter based on how much starlight it blocks. But based on its gravitational influence on the star, we know that it is at least 17% more massive than Earth. So it's probably, you know, a planet made mostly out of rocks and metals. It's probably belongs to a class of planets known as super Earths. Another thing we know about it is that it orbits its star very, very closely. Here you see its orbit on the left, that dotted blue line. Now look at the right is where if Mercury was orbiting Proxima Centauri at the same distance as orbits the sun, you would see it would be much farther than Proxima. So Proxima Centauri is orbiting its star very, very closely at a distance of only about 1/20th the Earth Sun system, and it completes an orbit every 11.2 days. We don't know if this planet has an atmosphere, a magnetic field, you know, volcanoes, oceans, moons. We basically know almost nothing about this planet. But one thing we do know, and this is what's really exciting, is that it orbits near the inner edge of the star's habitable zone. In other words, it's receiving about the same amount of energy from Proxima Centauri that Earth receives from the sun. So if this planet has the right kind of atmosphere, it can have liquid water on its surface. So it could conceivably support life similar to life on Earth, that's based on carbon and liquid water. There's one strike against the planet hosting intelligent life or, advanced life, however, and that is calculations show the planet is so close to the star that the star is going to tidally lock the planet. That means the planet will revolve around the star at the same rate it rotates on its axis, 11.2 days. So this is just like the moon is tidally locked by Earth. That's why we only see one hemisphere of the moon. So for this planet, Proxima b, one hemisphere is always facing the star. It's going to be hot. The other hemisphere is always facing away from the star. That means you'd expect it to be cold. But what if this planet has a thick atmosphere? Strong winds could even out and redistribute the heat to make the near side less hot and the far side warmer than it would otherwise be. So we really don't know. This is a beautiful, one of my favorite pieces of space art depicting Proxima Centauri as seen from the planet's surface. But, no one really knows what the surface actually looks like. But I think, this is a reasonable, educated guess. And is it habitable? Is there life? The only truthful answer is we simply don't know. Now here's another artist rendition where we see Proxima as the big star and the planet at the lower right. As I mentioned at the very start of the talk, this star is unleashing very powerful flares. In fact, a lot of red dwarf stars are known as flare stars. They give off very powerful flares. So this star is bombarding this very nearby planet with high energy ultraviolet radiation and X-rays, as well as high speed charged particles. So we don't know if this incessant barrage of flares would strip away the planet's atmosphere and make it inhospitable for advanced life. But the planet could have a very strong magnetic field. It could have a thick atmosphere, and these things could protect the surface of the planet so that life could start and evolve toward complexity. We just don't know. Making the system even more interesting is that astronomers using the same radial velocity method just a year or two ago discovered a second planet named Proxima Centauri c, seen here in the foreground of this artist rendition. This planet has at least 7 Earth masses, and it orbits its star every 5.3 years at about the same distance that Mars orbits the sun. So here the artist has depicted this planet as kind of a miniature version of Neptune. So given its distance from a very feeble star, it's probably too cold to support life as we know it. But who knows? We really don't know. We don't know if it has moons that could potentially support life. We don't know if there are other planets in the system, but there could be that we've just found the 2 that are the easiest to detect. So let me just take a quick water break. So you might be wondering, how can we determine if BLC1 is coming from ET? Well, I have no doubt that the Breakthrough Listen team is getting more observing time on Proxima Centauri with the Parkes Observatory to see if they pick up the signal again, if it repeats. They've announced that they're going to repeat the exact sequence of observations on April 29th, 2021, just a little over a month from now, which is 2 years to the day that it detected BLC1. They're undoubtedly looking at archival data from Parkes to see if this signal appeared in past observations. And undoubtedly, they're trying to pin down every conceivable source of human radio interference. But I suspect that they're also observing the star from other radio telescopes in the southern hemisphere, such as the Meerkat array in South Africa. Unfortunately, because this star has such a southerly declination, a lot of the larger radio telescopes in the northern hemisphere can't observe it. But I think we're going to have an answer in a few months. If this is, just, like a microwave oven, then the ET hypothesis will die a very quick death. But let's say they find that this signal's repeating, they may be detected at other frequencies, they detect it at other observatories, they rule out interference, then I would argue that this will be the greatest scientific discovery of all time. That is a radio emitting, transmitting civilization only 4.25 light years away. Now, some astronomers have said there's no way this can be ET, because what are the chances that we'd first detect a signal from the nearest star? That would be incredibly unlikely. But Penn State University astronomer Jason Wright, who we see at the upper left, has pointed out something really interesting. Imagine that there's like a network more than one civilization, or one civilization that's spread out around the galaxy. They could set up a galactic communications network analogous to the cell phone networks we have here on Earth. So let's say I want to call Steve here with my cell phone. My signal is not going to go directly to his cell phone. It's going to go from tower to tower, or node to node, and then eventually the nearest node will send the signal to Steve's cell phone. So if this is what the galaxy is like, and it could be if there's a lot of civilizations or super civilizations, Jason's pointed out, we would only expect to receive radio signals from maybe the nearest handful of stars. So I would agree with him. The fact that it's from a nearby star does not necessarily rule out that this signal comes from ET. So as I stated at the outset, it's probably radio interference, human source. But for the sake of fun, and it's a lot more interesting if this is a signal from ET than if it's a signal from a microwave oven or a car. So let's just assume for the next 10, 20 minutes, this is a genuine ET signal. That raises really interesting questions. What should we do next? Should humanity respond? Who should decide how to respond? And if we do respond, how should we respond? And who are they that we're trying to communicate with? What are their motives? Do they pose a threat to us? Okay, these are profound questions, and the answers are far from obvious. So, these questions would pertain to any radio signal we receive from another civilization. But, it's one thing if the civilization is maybe 1,000 light years away. It's a totally different story if it's only 4.25 light years away. Because think about it for a minute. We could send a response. It takes our response 4.25 years to get there to Proxima Centauri. And then if they decide to respond to our message, we could get it 4.25 light years later. That's 8.5 years. So we could get a response to our signal in less than 9 years, which is well within the lifetime of hopefully everybody on this Zoom call, and within the lifetime of most people alive today. So how cool would it be to have like a conversation with a civilization where we could get a reply to our message in your lifetime? What could be more exciting than that? Now, scientists, philosophers, linguists, other influential thinkers have given serious thought to the concept of METI. That stands for messaging extraterrestrial intelligence. So, until this signal, we've assumed it would be hundreds or thousands of light years away. But that would make it a safer distance, but would also make, this one-way communication, because we're not going to get a reply to any signal in our lifetime. So you can see that having a signal or having a civilization so close to Earth would be a game changer and would add urgency to the question of whether we should send out signals. Now, we have already attempted METI, but only at a very rudimentary level. So in 1974, the great radio astronomer Frank Drake used this Arecibo telescope in Puerto Rico, which was just recently, a few months ago, decommissioned, to transmit a message in the direction of M13. That's a large globular star cluster we see here on the left. That's 25,000 light years from Earth. So Drake's message will take 25,000 years to get to M13, and any reply would take another 25,000 years to come back. So we would get a reply in 50,000 years from now. I don't know about any of you, but I don't plan on being alive 50,000 years from now. But it's very safe to conclude that, any aliens out there aren't speaking English. So we need to find a common language to communicate with ET, and that's a major challenge. But, scientists, think that we could establish a common language for communication because we share a knowledge of astronomy, radio technology, and mathematics. So this is the message Drake sent to M13. It's in a binary code arranged in 73 rows and 23 columns. These are both prime numbers, and it contains, basic information, about our biochemistry, humanity, our location within the solar system, and the Arecibo telescope. He sent it at a frequency of 2,380 megahertz, but he shifted it in frequency by about 10 megahertz intentionally during the transmission. So the message is really more a proof of concept than a serious attempt to attract the attention of extraterrestrials. Now, since this message, there have been other attempts, mainly by private individuals and organizations, but it's not really being done at a really serious level. In case you're wondering, the most powerful signals that we're sending into space right now come from the North Warning System, which is a series of radar installations across Alaska and northern Canada designed to warn, of incoming intercontinental ballistic missiles carrying nuclear weapons from Russia. So these radio signals could be detected by other civilizations out to a distance of about 10 to 20 light years. So sending a detectable radio signal to Proxima Centauri is not that difficult thing to do. It basically means, connecting a very powerful radio transmitter, more powerful than our radio and TV stations, but, comparable to the ones on this, radar system across Alaska and Canada, and just connect it to a fairly large radio antenna. And you have to do this in the Southern Hemisphere, aim it toward Proxima Centauri. This is well within the capability of many nation states, but also wealthy individuals and organizations. So who speaks for Earth? Any message we send, it's not just a message from one organization, it's a message from humanity, but we also, I would argue, have a responsibility to all the life forms with whom we share our planet. So I would hope that any decision to respond would be discussed at the United Nations, and that people of many different countries and cultures would have a choice, a chance to voice their opinions. The problem is we're never, ever going to reach unanimity. We're never going to have a consensus agreement. I mean, after all, we're in the midst of this raging pandemic in the United States, and we can't even get people to agree on whether or not to wear masks in public spaces. So, I would argue that we need to set the bar very, very high, and that, we should get the approval of nations representing at least 3/4 of the world's population before responding. That's just my opinion. I would be interested to know what some of you think. And we would also have to take measures to make sure there aren't rogue nations or organizations or individuals who are responding without authorization from any international body. And I would also argue that before responding, we should try to learn more about our conversation partners, about the aliens at Proxima Centauri. So as an example, in the next decade, we could build a very sophisticated ground-based telescope. We see an artist's conception of one project known as ELF, for Exolife Finder, that in such telescopes could give us more detailed information about the planet orbiting Proxima Centauri. We could see, for example, if it has an atmosphere that has gases indicating there's life on the planet. We could also build, a super sophisticated space telescope, better than the James Webb Space Telescope that is launching later this year. Whoops. I would also want to build a large radio telescope on the far side of the moon using one of the craters. And this is a great place to do radio astronomy, because the far side of the moon is shielded from all the radio interference from Earth. So a big far side radio telescope on the moon could detect very faint radio signals coming from Proxima Centauri. Now, this is a really, really important point here, and that is, it is extremely unlikely that we and they, us and the Proximans, would reach the same level of technology simultaneously. So we developed radio technology, less than a century ago. So we have to assume that the civilization on Proxima Centauri is more advanced, and probably a lot more advanced. With their technology, they have probably discovered already that there's a third planet from the sun. They may have already studied our planet's atmosphere and discovered gases like water vapor, oxygen, carbon dioxide, and methane. If they have, they would conclude there's probably life here, and they may already have detected, very weak radio signals from Earth, or found other signs that there's intelligent life here, that there's a technological civilization here. Maybe that's why, if this signal's real, why they're sending radio signals toward Earth. It's possible that they're monitoring our progress and that they know a lot about us already. They could be biological creatures, or they could be machines running on artificial intelligence. Now, the late British physicist Stephen Hawking once said, and this is an exact quote, "Meeting an advanced civilization could be like Native Americans encountering Columbus." That didn't turn out so well. He also speculated that super advanced aliens could be, quote, "rapacious marauders roaming the cosmos in search of resources to plunder and planets to conquer and colonize. And for good measure," he said, quote, "they will be vastly more powerful and may not see us as any more valuable than we see bacteria." Now, on the other side of the debate, Carl Sagan argued that it's possible that advanced civilizations are highly enlightened and confident in their survival. After all, they managed to survive their own technological adolescence. So I think it would be equally mistaken to assume they're hostile. If we could establish communication, they could give us, possibly very important, valuable information to help us cope with, things like environmental destruction, nuclear war, violent tendencies, etc. So if this is a civilization, I would just argue we don't know if they're friendly or hostile or just indifferent. We just don't know. But if they are hostile and far more advanced, then I would argue that Hawking is right in the sense that we could be in grave danger. And this is not going to be like a cheesy sci-fi flick where they attack us and we fend off the attack, like in the movie Independence Day. If they're just a few centuries more advanced than us, they would have a way to wipe us out where we have no defense. As just an example, they could take an object smaller than an automobile, accelerate it to 99% the speed of light, and smash it into Earth. And this is what would happen to Earth. The kinetic energy would be so enormous that it would quickly wipe out almost all life on Earth, and there's nothing we could do about it. Or they could take an asteroid, maybe something on the order of the size that wiped out the dinosaurs, divert it and slam it into Earth at a much, at less than 1% the speed of light, and repeat the extinction of the dinosaurs 66 million years ago. And since we're in the middle of a pandemic, they could genetically engineer a pathogen, introduce it into the biosphere, and maybe within weeks or months, it wipes out humanity while leaving the biosphere intact. So, but I would think that for now, we don't represent a threat to them. So they would have no incentive to attack us. And I would argue, my guess is most of you would agree with this, is that our biggest danger doesn't come from ET, it comes from ourselves with things like nuclear war, climate change, environmental destruction being our primary existential threats. So for the final few minutes, I also want to discuss that Proxima Centauri's nearness has motivated the dream of interstellar travel. So Breakthrough Listen's parent organization is called Breakthrough Initiatives, also funded by Yuri Milner. And for several years now, even before this signal was detected, they've been planning to fly a mission to Proxima Centauri called Breakthrough Starshot. So the idea is you make about 1,000 tiny little spacecraft, attach them to light sails, and then use extremely powerful lasers to accelerate them to about 20 to 30% the speed of light. And at that speed, it would take them just a few decades to reach Proxima Centauri. So here we see one of these nano spacecraft. And even if, let's say, 990 out of 1,000 fail or get destroyed by interstellar dust or whatever, a few of them should make it to Proxima Centauri and collect data about the star and its planets. I'm not exactly sure how this tiny little antenna, though, could get the signal back to Earth. I have to do more research on that. So you could argue that if this radio signal BLC1 is real, we should send this mission, collect data inside the system to learn more about who these creatures are. But you could also argue the opposite, that the Proximans might see this as an aggressive move, something that is a harbinger of maybe a future attack or something like that. But I would say that we've been flying powered aircraft in our planet's atmosphere for less than 120 years. Of course, Kitty Hawk, Wright brothers, 1903 in your home state of North Carolina. But we're already thinking about sending an interstellar mission to Proxima Centauri. So that tells us that we're making extremely rapid progress in technology. And I would argue this absolutely suggests that interstellar travel is possible, especially between, star systems that are less than 5 years apart. And it also suggests that if there are ETs at Proxima Centauri, I would argue it's possible they have a presence in our solar system right now that they're keeping hidden from view. We don't, that's just speculation, but we can't rule out that possibility. So to conclude, if I had to wager a lot of money, I would bet that BLC1 will turn out to be human radio interference. And I think we're going to know soon, maybe weeks or months from now, we're going to know. But in the slight chance that it's the real deal, we're going to face some very interesting and important decisions, and we can, expect a lot of intense discussions at the international level in the years ahead. But even if the signal is not from a civilization, these questions surrounding METI are still fascinating because they force us to think about ourselves in a broader cosmic context. So I want to thank all of you for your attention. Here are 3 books that I highly recommend that touch upon some of these issues I talked about tonight. And on the right are 2 movies, Contact and The Dish. Contact is a movie about SETI starring Jodie Foster. The Dish is an Australian comedy starring Sam Neill of Jurassic Park fame about how the Parkes Observatory relayed the radio transmission from Neil Armstrong and Buzz Aldrin's famous moonwalk from Apollo 11. Now, neither of the movies are particularly accurate scientifically or historically, but they're both, I think, really good movies and a lot of fun. So I'm going to stop here. I do look forward to your questions, and certainly I would welcome, any comments that any of you have about your thoughts on whether we should respond to the signal if it's real, and just any general thoughts you have about these issues. I am going to run upstairs. I will be back in 2 or 3 minutes. Since this is the Science Tavern, I'm going to grab a beer, but I promise I will be right back.
Thank you, everyone. Please put any more questions in the chat, or you're welcome to unmute yourself when Bob gets back. Really interesting questions that he's raising.
I'm going to go ahead and link our YouTube channel again in the chat for those of you who might have joined us later. But there it is. If you want to go check out our YouTube channel, you can see our previous talks as well as this one will be. So if you have anything you want to watch again or questions that you want to revisit, you can go ahead and check that out. And that should be linked in the chat.
Yeah. And then also, while we're announcing next month's talk on Sunday, April 11th, is about microbes masquerading as minerals. It's a cave science talk about microbes found in Earth's lava caves that could also potentially be existing on Mars. So is there life on Mars in these lava caves? Who knows? So it's a very relevant talk, talking about life beyond Earth. Welcome back, Bob.
And I just want to say, here's everybody. I thought I'd drink beer from my hometown of Hershey, Trogue's Grand Cacao, since we're chocolate town here. So I'll drink a Grand Cacao, which does have a little bit of a chocolate flavor. So I want to say cheers to everybody, and thanks for tuning in tonight.
Oh, Bob, thank you so much.
Cheers.
I have a question. So this summer, I was actually writing simulations about this. And
Oh, wow.
Your point that, I was simulating the emergence of extraterrestrial intelligence in the galaxy.
Mm-hmm.
And you're right. Statistically, any other civilization that exists has likely existed since long ago. So long ago, in fact, that if it could see all the way across the galaxy, it would be able to observe the entire galaxy. Now, there are practical physical limits on how far a telescope can see, but we have no idea just how big of a dish a civilization might build in its determination to observe the entire galaxy. Now, what that means is that not only would the oldest civilization, the firstborn, likely be able to see the entire galaxy, it would also be able to observe the births of all other civilizations.
Yep.
Now, in all likelihood, you don't want trouble, right? So you probably don't want to start a war. And so if we assume that civilizations are probably not interested in killing, but that there may be some killer civilizations, the worst possible thing to be is a killer civilization, because then everyone wants to kill you.
Yep.
And so now you may have just not killed anyone yet, but if you do, then other people will notice and they'll try to hunt you down and eradicate you, right? And they know where you live, and they've known you since when, you know, you were throwing spears at wildlife. So there's no hiding, there's no escaping, they're going to get you. So from time to time, random killer civilizations will emerge, but they'll probably very quickly be eradicated. And so, yes, maybe the very first ET we meet is one of those civilizations, but I would much, much rather be part of an interstellar NATO that could actually protect us, or at least avenge us, than I would to just hope that no one finds us, because maybe a killer civilization would, and then there wouldn't even be anyone to take revenge. And also, if we're part of one, there might be a way to send a signal that we are, and that would deter any killer civilizations looking to do violence for sport.
No, that's a very interesting idea. One thing that I did for this talk is, and this is actually kind of how I feel myself, is I take an agnostic viewpoint as to how many civilizations there are in our Milky Way galaxy. And when I say civilization, I mean, you know, technological, you know, that can make themselves detectable to other civilizations or communicate or even traveling. And, you know, it's funny because I've written an article for both Sky and Telescope and Astronomy, arguing that, you know, technological civilizations are probably very based on the idea that Earth, you know, we've had life on Earth for over 3.5 billion years, but it took, you know, almost the entire history of Earth to get a technological civilization. But in recent years, I've kind of modified my thinking, and I'm now I kind of take an agnostic approach. I can envision a scenario where we're the most advanced civilization in the galaxy. We're, let's say, the only civilization that can launch things into space. But I also, you know, can imagine a possibility where there are, you know, hundreds or thousands of others in the galaxy. So I just take kind of an agnostic approach and to what their capabilities and motives will be. And like, my view is we just don't know. We don't know really who or what is out there. But what I will, and I definitely get the premise of your comment. If there are other civilizations out there, we're the young, you know, technological civilizations. You know, we've had radio for, you know, about a century now. You know, we're the youngest radio civilization in the galaxy. So if there's other civilizations out there, there are undoubtedly some of them that are much, much more advanced than us. You know, I mean, the planet started forming billions of years before the Earth did, that could have had enough heavy elements to like develop life. So the oldest civilizations could be hundreds of millions or even billions of years older than ours. And when you try to imagine, you know, if they continue on the technology curve, you know, it almost becomes mind-boggling, because they would be, you know, if you just kind of extrapolate our rapid progress, even if these other civilizations kind of at some point reach a plateau, it's going to be so far beyond anything we're capable of doing that, you know, it's very hard to extrapolate, you know, what they could be doing or what their motives would be. Everything you said makes logical sense. But I would just say we just don't know. I do give another talk that I've given to other groups in the last few months, where one of the things we should be looking for are what are called techno-signatures, signatures of like interstellar spacecraft, or like things like Dyson spheres, or evidence of like very advanced civilizations that are modifying their planet or doing big astroengineering projects in outer space. And that's something that's sort of the next phase of SETI, is to look for techno-signatures. That's something Jason Wright, who I mentioned in my talk, that he's given a lot of thought to that, of different kinds of techno-signatures that we could see from highly advanced civilizations, civilizations millions of years more advanced than us.
I'd
Great.
also like to add, it's not just the oldest
We need
civilizations.
to go to other people's questions. I appreciate the thought-provoking conversation, but maybe you guys can exchange contact information, but we need to get to other people who ask questions. Andy and Sally Thomas in the chat asked, if the planet is more dense and therefore more metallic, would the expectation be that its magnetic field might be appropriately stronger?
Oh, that's an excellent question. So the thing is, we just don't know. We basically know nothing about the planet other than its minimum mass and its orbit. That we do know. So the planet is presumably, because it's more massive than Earth, but not a lot more massive. Like, it's unlikely to be like 3 times more massive than Earth. It's probably somewhere from around like 1.2 to maybe 2.5 times the mass of Earth. So it's probably made, of a lot of rock and metal. We're assuming it's sort of a terrestrial type planet. So, a lot depends on its like rotation rate. Well, we know its rotation rate. It rotates every 11.2 days, where Earth rotates every 24 hours. So it's rotating kind of slowly. But I would say, yeah, if it had the right kind of, I actually wrote an article for Sky and Telescope about 2-3 years ago about planetary magnetic fields. And the magnetic field comes from the convective motions of molten, nickel and iron in the Earth's outer core. So if this planet has a large molten core, with a lot of metals in it, then absolutely, even though it's rotating slowly, it could still have the convective motions in its core that absolutely could produce a very, very strong magnetic field. Someone would have to do the theoretical calculations. Maybe someone has, but just kind of off the top of my head, I would say the answer to your question is probably yes. The planet probably could have a very strong magnetic field.
I think what I was trying to get at there, and first, let me thank you for this fantastic talk. I was really intrigued. Apologize for arriving late.
That's okay.
You seem to be building a case when I joined for maybe why this planet may not be able to be the candidate that might have a civilization that could have reached out and contacted us. And then you said, unless it maybe has a magnetic field. And I just wonder if theoretically, a physicist could model the magnetic field based on some scenarios of the way that the density of the planet was, if it was a much more Faroan or iron-bearing planet than ours. And maybe, you would be able to say, it still doesn't get there. Oh, it actually ekes across the line, and maybe it is. And so I just wondered. And so thank you for addressing that.
Yeah, I would just say, as far as I know, I think the premise of your question is a very good one. And I would have to think that, if this thing has a lot of metal, it's a fairly massive planet. It's probably, it's got higher surface, like Michael Jordan. I know, he went to University of North Carolina. He ain't going to be dunking on this planet because it's going to have very high surface density. It probably will be very dense. I would think there is certainly a possibility it could have a pretty substantial magnetic field.
I have a quick question. Do you know if the Breakthrough Listen team has been developing any protocols for how to respond to a signal as part of their funding?
I don't, that's actually a great question. That I don't know the answer to. I do that they have protocols for how they will, announce signals to the public. And that protocol was broken because this was leaked to the Guardian. And I'm wondering if they found out who leaked the story and if like they kicked the person off the team or something. I don't think they would reply. I doubt they would reply unless they got some kind of authorization from, like the UN or some international organization. As I said, I would really hope, I'm probably being naive here, that, someone probably reply without authorization, but I would really, really hope that, any reply is kind of some common message from humanity done through some kind of international agreement. I would really hope that would be the case. I would be against anyone, going rogue or going solo.
Great. And I think we have one more question from the chat, which you may have touched on in the talk, but Ken Steiner asks, how long was the signal received and did its cycle correspond with its orbit of the star?
Okay, great question. So once again, the team hasn't released the data yet, but based on what was stated in the interviews, they did only a handful of interviews. There were 5 pointings toward Proxima Centauri of 30 minutes each, and all during that period, they were seeing the signal. So that would be about 2.5 hours. And I'm sorry, what was the second part of the question again?
Let's see. The second part of the question was, did its cycle correspond with its orbit of the star?
Okay, that's a very good question. And it's interesting because every time I give this talk, I modify it a little bit so I don't get bored giving the exact same talk over and over. In an earlier version of the talk, I talked about the signal drift. So we don't know how much, but the signal was slightly increasing in frequency over the course of the observations. We know it drifted a little bit. So that could mean that the source was moving toward Parkes Observatory, causing a Doppler shift that would cause the signal, to appear higher and higher in frequency. Or it could mean that whoever was sending the signal was changing the frequency intentionally to go to higher and higher frequencies, or a combination of both. What we do know, and I can't remember who it was, but there was an astronomer who did a calculation that at the time that Parkes received this signal in April 2019, the inner planet was moving away from Earth. So that would kind of slightly argue against the signal coming from that planet, because the signal was the Doppler shift would imply it was a source that's moving toward Earth. But once again, the people, if there were creatures on this planet sending a signal, they could have adjusted the frequency, as their planet is moving. But once again, I don't know what the signal drift is, because the team has not announced yet, like the exact bandwidth of the signal, its strength, its signal width, or how much it drifted. So there's still a lot of the details of the signal that have not yet been made public to the scientific community or the public. One funny little story here. So I mentioned in the talk, Penn State astronomer Jason Wright. It is his graduate student, Sophia Shake, who is writing the paper up, who's going to be the lead author of these papers. She is his graduate student. She's studying to get her PhD at Penn State. what's interesting, and Jason told me this, is he's not on the Breakthrough Listen team. So even though he like interacts with her all the time because she's his student, she is not telling him anything about their analysis, even though he is her PhD thesis advisor. So since they leaked this to The Guardian and did a few media interviews, the team is being very, very tight-lipped and not telling what it knows.
Great. It seems like there's some good conversation going on in the chat. Might leave this running for a little bit, but
Okay.
I have to go. So maybe I'll hand off moderation to Stephen, but thank you again for the talk. Thank you all for your wonderful questions and discussion.
Thank you.
And again, you can find the link for our YouTube channel in the chat box as well. Have a good night.
Yeah, you too. Thanks for joining.
Yeah.
Thank you. It was great.
I think we'll bring things to a close right now, but
Okay.
thank you, Bob, once again for talking to us. We'd love to have you back sometime, and maybe before then we'll know more about the signal.
I hope so. I'm hoping we'll get an answer pretty soon, like within the next couple months. Of course, I was saying that a couple months ago, so hopefully soon. But I think certainly before the end of this year, we'll have much more information about the signal, and probably, especially if they can pin down a source of interference, we'll probably know that before the end of this year, maybe even, in the next few months.
But there's a lot of what if questions to think about in the meantime. So
Right.
plenty of food for thought. And once again, thanks, Bob, for joining us. And thanks, everyone, for joining us for the March Science Tavern. We will see you for April. And I hope you all are doing well. All right.
Thanks,
Take care,
everybody.
everyone.
Thank you.
Thank you so much. That was so great.
Beautiful.
Thank you.
Wow.
Bye.